All right, everybody be seated. We are just going to start the session. Please be seated. Thank you.
Welcome back, everyone. So let's start without delay. Um, okay, in this session, we'll take a quick look at um, AI and Gen AI, kind of just to ensure that everybody is on the same page. The first part of this, uh, before the Gen AI part, I will go very, very quickly, right? This is not a lecture on AI, right? If you want me to, I can do later. If anybody wants, I can explain things later. Not in the session, but later. If you have any questions, we can discuss. I can explain things later. But just to put things into perspective, right? So I will go very, very quickly at the first part, and then we'll um, look at the Gen AI and prompt engineering and what are the different things that you can do and so on, right? Okay, so we are not going to go into this, but when you're talking about AI or artificial intelligence, the first question that comes is what is intelligence, right? Because if you have to do something artificially, you need to understand what intelligence is, right? So that's a philosophical question. There's a lot of other things, neurological question, neuroscience, all those things. We are not going to go into that one, right? Because there are so many definitions, so many different things. So we are not going to do that, right? Because what we are going to do is to define this as we go, right? Because if you don't know what intelligence is, trying to define what artificial intelligence is a more task. But let's try to do things as we go, right? So what is AI now? Now, very quickly, the AI. Now, why are we doing this workshop particularly? Why is there so much hype and interest in AI? Because the things have changed so much, right? We need to understand the significance of it. Why it is significant is because we need to understand, if we are to project the future and envision the future, we need to understand how things are changing, right? I started teaching AI about 10 years ago. Now, I did this, I would ask my class, when you think about AI, what do you visualize? What do you envision, right? If I asked this question 10, 15 years ago, the answer normally is basically this. AI used to be movies, right? 10 years ago, if I ask AI used to be movies, there'll be few examples some here and there, right? It's just like, it could be AI or Star Wars, R2D2 and C3PO or HAL from 2001 Space Odyssey. But then things started changing about 20, 25 years ago when Gary Kasparov, the world test master, was defeated by Deep Blue 2 in 1996. And then we saw IBM Watson becoming the Jeopardy champion in 2000, around 2009, I guess. I can't remember the dates because things are changing so fast. And now things have become so commonplace, right? Whether it's automated car, smart agriculture, medical imaging, and even Google. I mean, Google knows more about us than we know about ourselves, right? With the use of AI and everything, they will track us. We go somewhere, they will give us advertisements and everything, you targeted things, all those things, right? So AI has moved so rapidly over the last um, uh, 10, 15, 20 years. And now we are with ChatGPT and Gemini and all this Gen AI tool, which is why we are having this one. But before we move on to understand where we want to go, we need to understand why it is changing like that. Why did it change like that? What happened? Did AI had so many breakthroughs in the last last 10, 15 years? AI didn't have many breakthroughs actually. It did. I'll be lying if I'd say it did not. But what really happened is not that AI came up with a lot of new theories. What happened was AI needed two things. AI needed data, AI needed computational power. Yes, exactly. That changed. In the turn of the century, we started IoT, all those different things, spend sensors and everything, and we started digitalizing everything. And suddenly there's a deluge of data, and we came to the age of big data, and now we are generating data more than we can consume. And also, one smart guy and others, the Hans Jensen of NVIDIA, they invested on this using massively similar data and processing them together. So NVIDIA, even though it came out as a gaming card, it's driving the AI revolution. So we need to understand the theory or the knowledge didn't, I mean, it is now evolving very fast. But what happened is we knew these things. These algorithms were available 20 years ago, 30 years ago, 40 years ago. But we didn't have the computing power. So human ingenuity, creativity was that far ahead. It didn't have the technology to support it, right? It's changing so fast. And the rate is changing is so scary in a sense, because when I graduated 20 years, 22 years ago, I had a dial-up modem with a connectivity of 64 kbps, right? It's a joke now. Right? So need to understand, like, we are looking at next 10 years, 15 years, how it's going to change for my kid. We have no idea, right? So that is what we need to kind of envision, like, where is it going, right? So anyway, just to leave you that thought, let's move on, right? Just to kind of demystify with the rest of what is Gen AI. Before Gen AI, why is it generative? What is the other? Right? So we are talking about this evolution of AI. We have seen AI from 1950s. People are talking about a lot of topics. I'm not going to go into the details of those. And then we see in the late 80s and 90s, we go into what area called machine learning, the ability of the machine to start learning. And it started doing things. Didn't have the computing power much, but it started doing things. And then in the last decade or so, we see this deep learning with the evolution of technology, with the availability of computing power, the availability of data. We see this deep learning and new models coming in, new ways of doing things coming in, right? So this is driving this entire thing very, very rapidly. And these things are happening very, very fast. So we came up to deep learning. Now we are talking about generative AI, right? If we don't, as I said, if necessary, we can have a discussion about this one, but this is evolving very, very fast. These are all fields inside of each other, right? Becoming very, very specific as we go, right? And we see this evolution. So once again, I said this evolution was not very straight line. Starting from 1956, we had a huge boom, lot of research funding, and everybody realized, okay, they're saying a lot of things, a lot of theory, a lot of publications, nothing coming out. Crashed. And then we see with Deep Blue and all that, sudden increase again realizing, okay, nothing is happening. Again, a crash. Now we see a rapid boom. Where it end up, whether it's go like a rocket or whether it crash in the next 10 years, we have no idea, right? So we have to be aware of that as well, about the limitations and all those we are talking about. We have no idea where this is going, and all this hype, or even this, what we are trying to do today, whether it will be successful or not, we have no idea. We'll try, right? That's the whole only thing that we can do. We'll try as much as possible to do these things and get the best out of it. Right. And also, we have we have these three stages of AI. At the moment, we call this as the weak or narrow AI. So the narrow AI is that you can design an AI system to drive a car, or you can design an AI system to control a greenhouse, right? Or scan the resumes and identify whom to call for interviews. So we call this narrow AI or weak AI, basically for one particular task. So they can't do everything. So that is already done. Jobs enhanced. So this is what we are trying to do as well, using AI to enhance the operations of NREN. That's a weak AI or a narrow AI, just for one particular task, right? But we are also seeing that we'll get what we call the artificial general intelligence. machines which will be capable of doing broad spectrum of tasks, right? They are predicting it might happen in the next 10 years, 20 years. Who knows? We have no idea. But they're predicting it will happen. And then what is called artificial superintelligence, that machines that will be smarter than us or humans in every way possible or many ways as possible. Whether humanity will be at risk at that time, whether all these problems and all this coming in, we don't know. Right? Nobody can predict. But we need to be aware of these things, what is meant by this humanity as risk, even that we will look at, right? So just a quick glance of that. And looking at components of AI, these are things that you have probably heard. Machine learning, of course, you have heard, or at least I mentioned previously. Natural language processing. How many of you have heard what natural language processing or NLP? What is meant by NLP? Natural language. What is meant by natural language processing? Yes. Why? Because what is the other side of it? Computer languages, formal languages, very easy to do. Natural languages, very complex, right? For computers to understand exactly. I mean, if you include, let's say, for even speech recognition. So if I say, for an example, if I say ice cream, yes, ice cream could be the eating one or the screaming one. It could be both. It could be either of them. How do you know which one is which? By the context. Because human language is very, very complex. It's based on the context. It's based on the nuances, all those things, right? Even dialects. Like even within the same country, what you say will be very different. So it's a very, very different, what they say, right? If your wife says, go ahead, never do it, right? That's what they say, right? So computer will not know that, right? Yeah, right? So it's a challenge, right? But computer won't know. Go ahead means do it. Husband also don't know. Yes, exactly. I have learned hard way. Anyway, so this is natural language processing. Computer vision. Computer vision is actually now far superior to human vision, right? Doing all those things. Robotics has been there for a long time. So that's basically pretty much the breakdown of it. Machine learning is something that everybody talks about. So let's just take a quick look at it and move on to the rest. Machine learning, when people talk about this makes it very, very complex. People think this is a very huge task. Yes, the underlying stuff for the computer engineers, computer science is yes. But what is machine learning? It's learning. It's how people learn anything. Machine learning, we can break it down to three things. Supervised learning. What is supervised learning? If any of all parents would know, how do you teach your kid what is a dog or a cat? Or what is blue or red? So you keep saying, this is blue, this is blue, this is red, this is blue, this is red, right? You get the data, you label them, and you show enough to the kid, they will learn. That is supervised learning. There are many algorithms to do it. There are many ways to do it depending on the data and all that. Data has to be correct though. If you show your kid blue and say it is violet, right? I mean, of course, problems are there. Like, my son would now come and say, no, that's what is this turquoise, whatever, all the shades of blue, I don't know. I know light blue, dark blue, that's all, right? My son would come and say all this. But if you rightly label, that is fine. But if you wrongly label, they will learn wrong, right? Unsupervised learning. Unsupervised learning is like, how you learn everything else. Smallest kid. You can't tell them, give them labels. They learn every day you see, and it's your mom or the person who cares for you, right? And they start they understand the humans and probably animals. They cluster them. These different types of creatures. This is different type of creatures who are connected to me. This is an object, right? So they learn this is hard, this is right. So this is clustering. They just don't know what this is, but you can cluster and learn. We do it from the day we were born. So unsupervised learning, as simple as that. Underlying theory, of course, is not simple, but it's simple as that. Reinforcement learning. Again, take a kid, you touch fire, you get burned. You get negative reinforcement, you learn. Right? You do something good, you give them a treat, they learn how to do the good thing. It's once again very, very simple. Right? The way it is done, the underlying theory, underlying algorithms, all those things could be different. There are so many theory. I'm not going to show any of those things. If you are interested, you can go and learn, do computer science, computer engineering, and learn. But machine learning is not, it's basically, as you can understand now, if you have enough data, you see enough data, you learn. Right? That's why if you say a kid, don't go and touch that plug point, they will not listen. They will go one time they go and touch, they won't touch again. Right? Yeah, exactly, right? So this is, if you have data, you will learn, right? So this is this is what it is, right? So it's predict the next value, or identify clusters, or learn from mistakes. Very simple, nothing more than that. Understanding images and video, again, coming into the picture, right? So we can do face detection, optical character recognition, automatic tagging of images, drone terrain mapping, virtual reality, image generation. Why is this important? Because these things are already available. The tools are already available to do these things. And we can use these tools, right? Things like OpenCV, you can get images and use tools. There are all manuals to do how to use these tools. You just can just get the images and automatically tag, identify, and use it for, can create the data that you need for your work. So you don't have to worry about how it is done, because that is done for you by other people. Image generation, which is actually generative AI's part, right? And natural language processing, as I said, there are a lot of different things, right? You know, sentiment analysis. So understanding the sentiments in the text, right? Not just the meaning of it, the sentiments of it. What does it mean, right? Machine translation, summarization, question answering. So if you look at these things, this is kind of like the help desk for all the tasks that, most of the tasks that we are doing in office work and other places, right? Using a chatbot, you know, you get customer support help desk, right? If you can automate that one, question answering machine with a voice assistant, if you can combine these things and get it with your content, you're done, right? All your work is done. So there are a lot of things that are already available, right? So what is there and how you can do it is, okay, I'm going to skip this one. Now, another quick one before I move. Right. Now, a lot of people kind of confuse or what do you call, use the wrong terminology, or um, they say things when they mean a different thing. Right? These are all overlapping areas. If you look at artificial intelligence, machine learning, data science, big data, data analytics, people use these words interchangeably, but it does not mean the same thing. Big data is important because we have the data, and data science. Like, okay, let's go to data science. Data analytics. What is data analytics? Exactly. Use data, analyze, get something. Do you want machines to do it? You can use machines. But data analytics we did for centuries or millennia. People use information and deduce things, came up with things. Pythagoras and all those, they did the data analytics, right? You can do it, right? You don't need machines for data analytics. Like, it's statistics and data, right? It has been there for generations, I mean centuries, right? So data analytics is not the same as data science. Data science, you need both the statistics as well as the machines, right? Data science is not machine learning. I'll quickly explain later, right? But they have a huge overlap. It's not to say this one is different from the other. There's a huge overlap, but there are separations as well. We'll try to quickly understand, because when you're trying to do the things, like, you know, you look at what you are doing, right? And you want to automate them, you want to streamline them. You need to understand what do I really want to do, right? So let's quickly look at it. Before moving on to that one, we need to understand this one. This is why we are doing this workshop, and what we expect from this workshop. We have the computer science IT knowledge, and you put it into maths and statistics, it's machine learning, right? I can do machine learning all the time. I get data, I put computer science theory into it, I can do machine learning all the time, right? A lot of people do that. A lot of people publish like that way. But if you want to solve a problem in any domain, whether it's agriculture, whether it's airline industry, whether it's in NRENs, you need to have the domain knowledge, right? So if I want to go and have AI solution, a machine learning solution, or Gen AI solution for medicine, I need to have doctors here. A lot of times, computer people, IT people think. So that question that you asked, is it for IT people? Absolutely not. It's not for IT people at all, right? We need the domain experts to come in. If only the domain experts come in, we will be able to solve the problems in those domains, right? We need to understand the problems, underlying problems, and how the data works. If you have the analysis, we will tell you or show you what might be possible to do, right? And we can bring in people to help you to develop those things, right? So that is the whole idea, right? We are not going to tell you, like, no, this is what you're going to do and how you can do it, because I don't know. Right? If you ask me how to solve a problem in agriculture, I have no idea. Right? I can show you. Okay, if you provide me enough data, if you know this, we'll find this computing power, and these are the things that you might be able to do. Right? Can you label the data? Okay, then we can do this. Are you generating too much data that is impossible to actually label them properly? Yeah, well, then we will try different approach. Right? Right. So quick lesson on reality. So supervised learning, what should you look at? So people think when it comes to AI, what you should try to automate and do with the machines are the complex tasks. No, we are good in complex tasks. We can put many things together and come up with the creative, innovative ideas. Computers are really good at very, very simple tasks, right? That you can do with like a 1 second thought, right? So for example, you look at an email, you know it's a spam. How good are the spam filters in your mail client? Google, probably really good, right? In local things, there's not much, right? Why? Because it's very hard to detect. But when you see an email, you know it's a spam most of the time, right? It's easy to detect. Speech recognition, machine translation. You see an English word, you know what it means in Hindi or Sinhala or Urdu or whatever, your local language, right? But English words have many meanings, right? So for example, if I say pride, right? If I say pride, what the meaning of pride? Yeah, it's a feeling like, you've been proud and all that, right? That's one of the meanings of pride. It also goes with pride of lions. Pride of lions means a group of lions, right? Same as school of fish, right? So pride has, so if you take English words, any language, you have multiple meanings. You have primary meaning, secondary meaning, tertiary meaning, and so on, right? So like, teaching that to a machine is not straightforward, but you can do it, right? Because it's like when you see school of fish, it's not a new school that is open for a school fish, right? It's a group, right? So we can do that, right? So all these things, like, looking at any defective things and realizing that it is faulty. So all these things very easy for us to do. If it's very easy for us to do, we can train the machines to do it quickly as well, right? So what can you do to machine to learn? Learning a simple concept, lots of data available. So this is to move forward from here, you need to understand this part, right? If you have to automate things, if you have to streamline things, it has to be a simple concept. You can't do complex things. You can connect combine so many simple concepts and make a complex thing. But you can't train something to do a complex thing straight away, right? You can have to break it down to simple tasks. One task at a time, one simple task at a time. You have enough data and you can train it, right? So that is that next important thing to try to understand. Now let's think about, for example, one of the things that we were looking at at Learn, simple procurement process. Procurement process, you buy things to this one, you have to make a request, identify the specifications, identify the buyers, the vendors, send out the tenders, get the tenders, evaluate them, one task at a time. If you can break it down to each task, then you can automate it. You have to understand each step, which is very simple to do. No? Evaluating the bids. You look at the specifications, you look at the prices, evaluate. Done. Right? So this, like, breaking down the task to simple task is the most important thing when you're trying to use AI and Gen AI in your automation, streamlining tasks, right? And you need to have a lot of data. You can just, like, I'll explain what it means, right? So self-driving car, right? So this is self-driving car, which is happening. Like, so there's a vehicle in front of you. You see enough images. You input a lot of images. It will learn to identify what a vehicle is, right? After a while, it will learn how to detect the speed as well, right? And these are some pictures from Sri Lankan police. You might not know, or you might realize this. These three hand gestures, which looks almost identical, are three different things. If I can ask Tuan, what does it mean? This one means stop, right? This one means, first one means stop. Stop. This one says, go to this side and stop. This one, please turn and go. Looks almost similar, but means three different things. This is not going to help us to train anything, right? It will confuse. So this is the importance. So if it's unique and have enough data, we can train, right? Similarly, like, let's say extra diagnosis. If you have 10,000 labeled images of pneumonia, the machines would probably, I mean, we had a similar recent project of detecting oral cancer. If you have enough images, you can learn it. But if you take a medical textbooks, there are like 10 images maximum in a textbook. Doctors will learn from it because their teachers will tell you what exactly to look at and all that. They will learn. But you can't train algorithm. Now, one of the key things I have to mention once again. I said earlier, importance of correct data, correct label data. So there's a classic example about 10 years ago. This machine learning. People were like, military was designing machine learning algorithms to detect enemy tanks, right? So they had images of enemy tanks and images without enemy tanks so that you can identify enemy tanks, right? Tested, working well with the thousands or hundreds of thousands of images they had. And then they put it into the field and it failed spectacularly. I was like, what's wrong? What went wrong? Now, what they realized is that the pictures of the tanks were taken when it was bright sunlight. And the pictures when there was no tank was taken when it was cloudy. And the machine doesn't know there's a tank or not. It will just look at the images, analyze, and learn from the data. It's just numbers to the computer, right? You will see it. And if you show a kid, tank, not tank, tank, not tank, the kid will figure it out. Kid will not see the light and the darkness. But the machine will only see numbers. So it learned sunlight, tank, dark, not tank, right? So it's importance of data, right? So it's so my message from that one is you will fail and you will have pitfalls along the way, because the most important criteria for all this automation AI is having proper data. That will take time, especially in our countries. I don't know how it is in Pakistan or your countries. In Sri Lanka, we don't have data available at all, right? Even the data available are not that good at all, right? Digitization and digitalization are still happening in stages. So if the data is not good, will fail. It does not mean AI is bad, or the automation or streamlining doesn't work. It just means that the data is not good. If garbage in, garbage out, right? Simple as that, right? Right. So once again, two different tasks about machine learning and data science. Data science, machine learning is learning to do things, right? So you get enough, you see enough of doing, and you train how to do it. Data science is just looking at data and coming up with insights, hypotheses, and all that. Not huge difference, but where significant difference as well. What is that? Is that you get the machine to do something, right? You get the machine to do something versus you just look at the data and do just wait on the side. Two entirely different things. So definitely before you go to machine learning and get the machine to do it, you have to do the data science part first, right? Because you need to know that you are working with real data, good data, and what side of insight it has, right? You need to know when the vehicle is moving, you don't train it and just put it into the road and see whether it can detect a kid running across the road. First, you have to see, whether they can identify kids running across the road. Then you can put it into the practice, right? So anyway, I'll go skip the examples. I'll share the slides for anybody interested, right? So, for example, a recruitment, right? HR, you can just have data science things, you get the things, you can break down the step. Each part you can use AI to do the screening, schedule the interviews and all that. At the beginning, this is how you will use AI or technology. You're not going to streamline the entire thing. Like, machine learning, you get all the is submitted and you screen and bring out the possible candidates from the bottom. That's not going to happen day one. What's going to happen day one is that, or day 100 probably. Then you can move on to this side of doing entire thing together, right? Okay, let me skip those. Right, once again, the importance, yes. Science is usually, data science is used when you use, I don't know, it is using machines to do the data analysis. Yes.
Means when you use data analysis, it means that we are doing manually. But when we use the term data science, it means that
Yes.
machines are doing
I
that.
mean, that is the official definition. As I said, there are all overlaps. People use data analysis when you do it in machines, but if you look at the theoretical fields, data analysis means you don't need any machine to do that. You can analyze data. Data science, you come machine, and the computer science comes into that one. That the theoretical definition. We don't have to argue on that one. I can say data analysis, and we can use machines. Okay. Quick thing before moving on, we are trying to look at what the AI will do and all that. This is the first question, most question that most people ask: will it replace my jobs?
I had a session with one very senior Google employee, and he said that when the calculator were introduced first time, everybody was say that now we will be stupid in future because we are not going to use our mind for calculating. Now everybody is using calculator, but still we are using our mind. So sometimes things came just to help us, not replacing us.
Yes. Okay. So you answered the entire thing. Yes.
Well, I think AI can be perceived as a tool to assist. Yes, obviously, if someone doesn't learn AI with this emerging trend, then he may lose his job. But it depends again. Either the job requires human labor or it requires mental capabilities.
Yeah. Excellent. So my next few slides is gone. Yes. So I'll just stop at this one. As I said, you need reskilling, you need upskilling, and all that.
Yeah, I would like to say a few words about like losing jobs. To me, like new jobs will be created in the future. Like AI, in simple words, is like we are feeding machines to do something which humans are doing. So it is simple, like. So with the passage of time, we will see new jobs emerging in the market, even jobs like which we cannot imagine now.
Yes, really.
So there's
Okay.
no need of
Yeah.
worrying.
So this is World Economic Forum Futures Job Report. You know, they're saying that more than what we lose, we'll actually create more jobs. So this is like, you know, preaching to the choir. So I'll just skip this. So basically, the idea is AI is not going to replace you. Somebody using AI will, right? So that's the importance, and that's the importance of this session, right? So there are enough places that you can go and learn these things for free from the world's foremost experts like NREN from Stanford. These are freely available. If you want the certificate, you have to pay. But otherwise, you can just go and follow these courses in deep learning AI. And all, these are available in Coursera and other platforms as well, right? So you know you can go and learn how to do those things, the fundamentals and all that. Right. So that's a quick look at what AI is. Um, Hope you got something. So let's move on to generative AI, right? As once again, I'm not going to go into any of the theory or anything. Um, just to understand, what generative AI is, that it will generate things, right? So let me go to this one. So what's the difference? What happened to the traditional AI? So traditional AI, as we saw earlier, is what we call predictive AI. You look at things that happened, you look at the patterns and all that, you just learn to do it the same way, right? Same way, no difference at all. So you learn how to how something is done. So spam, no spam, and all that. Then you will learn with the prediction. Okay, this is a similar to previous one. Then then it is has to be something similar, right? So it's a predictive AI. Based on the previous data, you predict what this next one might be, right? Generative AI is learning from all the data and coming up something entirely new. Okay, generate something entirely new. But I mean, this is the question that a lot of people ask. So is it really entirely new? Exactly, right? So I mean, I have a crowd which like really know the stuff. Then my job is done. Maybe we'll just cancel and go for lunch. No, it's like, so right, it's creating, like, because I didn't create single language or English language. So I, like, as the slogan in Google Scholar goes, we stand on the shoulder of giants, whoever that went before us. So everything that went beyond before us, we will learn from them and we'll do new things, right? That's the human ingenuity, right? That is what makes humans different from animals as well, right? We can aspire to new things, we can hope for new things, and we can do new things, right? So that's the difference. So can we get the machine to do that, right? For how long, how much, for how much extent, we don't know. But at the moment, we are doing fewer things, right? We have generative AI creating new context, like content, like text, images, music, etc. So large language models, LLMs, are the ones dealing with text. So ChatGPT or GPT and Lambda, all those things are examples of those large language models, which are the basis of ChatGPT, Gemini, Claude 2, and so on. Right? So they have text-based generation. So GPT is a specific form of that large language model. But those are not the only Gen AI. We have generative adversarial networks, which are used for images, diffusion models, which are again for images. So we have different models. We don't have to worry about this theory, right? It's not important at all. Because these models are there, these generative tools are there. We can just use them and see what it does, right? Why bother about, how many of you have, I don't know, how many of you have opened the bonnet and see what's inside the hood in the car? If you even look at, do you know what's going on? Even I am from engineering, I don't know, right? I don't care. I know only thing is that, I push the accelerator, it moves. I push the brake, it stops. Good enough for me, right? So this is what we are going to do. Look at what happens when you push, push. Very good question. Excellent question. Should we be like drivers? So there's a difference. Now, for anybody who's driving a car, right? So any normal driver, you will just drive and you see those drivers, majority of them. If you understand the little bit of the dynamics, aerodynamics, and the understeers and oversteers that is there in the cars, then you'll learn to control your car better. Now, if you have watched the movie, what's the name of that movie? Niki Lauda and James Hunt. Anybody remember that movie? Can't remember the name of that movie. So it's Niki Lauda and James Hunt, Formula One race car movie that was from like the 70s. James Hunt won one time Formula One championship. Now, if you ask anybody any one of them, or Lewis Hamilton or Max Verstappen now, they understand the minute details of their engines. They understand the slightest bit of what will happen when they change. Like that's the difference between the top layer Formula One driver and the next level of Formula drivers. That's the difference between the next level of Formula One drivers and the race car drivers. That's the difference between the race car drivers and us, right? So if you learn how these things work, you will know how to get the maximum out of it. It doesn't mean you can't drive a car. So you can learn generative AI and AI and still do a lot of things without knowing anything how things happen. But if you learn little by little how the internals work, if I push this a little bit, what will happen? If I brake, if I accelerate and get my handbrake on, what will happen? You'll do a donut, right? So those things is the understanding the dynamics, right? So excellent question. So, but do you think Lewis Hamilton got in a car and learned about the internals first? No, he just got in a go-kart and start driving, and then you start learning about the internals, right? That should be our win. That gentleman's question first. What we do in our universities is first teach them all the theory and now put in a formula car and say, go and drive. They can crash, right? We should not do that. We'll start working, we'll start using, and then start learning about the internals little by little, right? So, what I said earlier, like what changed? This is what changed. Now, this is actually this image I generated from ChatGPT itself. The amount of data that we are using. So, latest GPT-4 it has 1.7 trillion data points, right? That is the amount of data that GPT-4 is using. So like 5 years ago, when these models came, BERT and the other models, they had about 340 million. Now we have 1.7 trillion. That was actually a few months ago, right? Not GPT 4.0. It's GPT-4, right? So it's changing rapidly. The amount of data that we are using to generate these things. One other thing, how far will this go? If you have known this Gartner hype cycle, every new technology trend, everything follows this Gartner hype cycle. So you can see all the new things. So everybody, like when they come in, they think, oh, this is going to be the next big thing. It'll have a big hype. Everybody is doing this. Even we are doing this now, right? So then you come to a kind of what you call a trough of disillusionment, where you realize it is not so rosy and not so good, and then come to the realization what's the real worth. So generative AI is somewhere there at the top, kind of really, really hyped now, whether it's crash and go that way, but it never goes to zero again, right? You will realize the real worth of it. Now this is an attempt to do that. What can we do with it? Right. Before moving on to the practical stuff, this one and the next session, the concerns that you, right, what you are working on. So Will, right? So ethical concerns. So what are the ethical concerns that you have, right? We'll come to this again later, right? But we are working with a lot of data and we are generating new things. So you have all of, I assume you have heard of this, the concerns or risk that we have, misinformation, right? It will generate just rubbish or use existing data specifically from sources that is published as rubbish, because we have enough data sources which are rubbish, right? So it might generate from those rubbish sources and come up with. This has hallucinations. What are hallucinations? Things that totally out of the blue, nothing in reality and all that. It can hallucinate, right? And you can. So if it doesn't make sense, you ask somebody some question, they come up with insane answer. Just like, are you sure? If that, I hope you have done it. If with ChatGPT you have not, if it comes up with answer that it doesn't seem good, just go and ask, are you sure? More often that it will say, okay, extremely sorry, I made a mistake, and give you a completely different answer, right? Yeah, exactly, right? So yeah, it does that, right? Right? And biased output. Now this is like if you like, what we need to understand. So this is one of the most important things about Gen AI. That is why we want to create this this workshop and the content here, because if you go and ask you to create an image of a boy, it will give you a blonde-haired or a white person, definitely, right? Because that's the most of the images that they see. If you want it to look like Asian, like us, you have to specifically say make it South Asian or make it Asian, and then it will give you that output. So it's very easy to see in images. So go and do it in images and ask to create scenarios, and you will see it will create almost all the time. It will create Western background images, white people, white cities, and all that. If you want it to create things that relevant to you, you need to specifically say, create an image with South Asian looking people in Islamabad. Then it will show the streets and all that, the way it looks like, it should look like, right? So this is like, so you can do that. We'll look at that, right? So the other side of the problem is that privacy concerns. If you put your data, now say that you want to do this in PERN or in your system. If you put your confidential data, what will happen? Who will see this one? This inadvertently, not that Google or OpenAI is going to share this information. Will it come in somebody else's report? Right? Or something that is generated. So for example, Singapore is very, very specific about their data security. I think Pakistan is the same, right? So they are developing their own Gen AI, because they are not going to put it into the public Gen AI sources, right? So if you have those concerns, especially if you have the laws, if the laws are there, you have no way out. If the concerns are there, maybe you can just go and try. I don't know. Especially based on how important and how critical that data is, right? And privacy concerns. If you put your data, will somebody see it? Especially if you are developing Gen AI tools, for example, let's say health-related ones, right? Will somebody's information get out? Right? Because health information is highly confidential, right? Should not go out, right? Financial information. Can it go out? Because we don't know what's happening. That's the beauty of it, because Gen AI, nobody knows what's happening, right? You generate it, you generate the models, you feed the data to it every time. So I mean, I assume you have done this thing. You go to ChatGPT, you go to Gemini, you ask a question. If you ask it 10 times, you get 10 different answers, right? Unless you're very, very specific, then you will start seeing like a similar answers. If you ask a very generic question, you start seeing answers which are very, very different each time you ask. Why? Because the model is such that it will go in different directions and give you different answers, right? So we need to understand, like when we have our own data and all that, where it comes up, where it pops up, we don't know, right? So we have to be aware of that one. And so these are all unintended, what do you call, errors and other things, right? The other side is the nefarious part of it, the intended bad effects, people using it to do damage, people using it for bad things, right? Like deepfakes, exactly, right? So you can use it to impersonate people, to create fakes and all that. So it has a high, it's basically very, very easy to do, right? You can create those things. So you need to understand how that can be done, and what are the implications of that one, right? So since this is not a talk on the ethical principles, so we won't go into the details. The other one is actually how to use. So understanding the limitations and the possibilities, right? You need to look at how to use AI responsibly, right? To come up with the guidelines, come up with the policies, not to restrict, to use its potential, but to ensure that its harmful effects are mitigated. Not only that, improve the benefits, the collaborations, the social impact, right? How to make it human-centric. Because AI, as I said, it's not about the technology, it's about, bringing the quality to us. Okay, so let's move on from there to prompt engineering and use cases, right? So we will just look at a few quick examples of different things, and I think we'll have to stop in 10 minutes because we will have lunch, and then which will be followed by the opening ceremony. So we can't delay this session like the morning one. So we'll look at different type of users. If I have time, I'll get different users from you all as well, right? And we'll wrap it up then. And then in the afternoon session, we'll have a hands-on session on what are the different ways that you can use this prompt engineering to get what exactly you want, right? So what is prompt engineering?
That how you are instructing your chat GPT or Gemini.
Excellent, right? Yes. Basically how you ask a question, right? Depending on the ways you ask a question, your answer will vary, right? What can you do with it? As I said, we'll look at it, but I'll just show you a quick example, right? So this is just like, I mean, it could be a simple question, like, I one day I wanted to remember one particular word. It didn't come to me. You could have done with Google search easily, but now you rely on ChatGPT even more, because it's like, you get not just a answer, but it look at all the sources. It looks at like, give an example, all that, so now even like Google search type of thing, like, if I want to know something kind of knowledge-based thing, I will actually use ChatGPT or Gemini, because it will give you exactly what you're looking for with the explanation and all that, and you don't have to go to any other source, right? So just a very simple question. And then, now I mean, it's become so like, I don't know. I don't know what to do without Gemini and ChatGPT now. It's like, I want to create, like, we had this, we created a new grants and um, projects division at Learn. I wanted to come up with nice name. Like, okay, we are doing this. We are creating a specific arm to handle our grants and our projects. Can you suggest some names? It came up with so many names and so many this. So we call it Learn Bridge now, based on a name that is given by Gemini, right? And it has meaning for each letter as well, right? So an acronym which has meaning as well as a nice name, which also it's about bridging our work with the future. So now earlier you have to think a lot and all that. This takes about, I don't know, 5 minutes, right? You just type. I just chat with Roshan. Roshan, what do you think about this one, this one, this one? Okay, let's fix on this one. 5 minutes, you're done. Come up with a new name. Like, earlier, like you had to go to linguists and all this, all this, all that, right? And all done. And I mean, learning is like, any field you do, this is, I mean, because I'm a teacher for first and foremost, right? I teach like, all the time. That's my primary job. And like, so I would explain a lot of things and, try to make sense of it. Now most of the time I do this online and I get the students to question. And if you ask the question, ChatGPT or Gemini answer would always be better than any answer that you can find. Why? Because it will summarize and give, like, let's just look at this one. What is biotechnology? Right, so I asked this one, and then it gives me the type of biotechnology: medical biotechnology, agriculture biotechnology, industrial, environmental, marine biotechnology. Like, it just breaks down the entire thing. Like just like, just reading one page is done. Right? It's done. Like, okay, this is like still, it's like, I have no idea. Just make it simple, please. Right? Give me a short and simple version. Right, okay, biotechnology is a field of science that uses living organisms and their systems to create useful products and technologies. It covers these areas. Now even my son can teach. My son is 14 years now. So like, even he can easily understand this one. Right? So the same thing. There's no textbook that does this. Right? There's no Google search that does this. Right? So we can, so that's the prompt. Right? I can actually continue also, right? So I'm telling it, this is too complex. Just give me a simple answer, right? Those are simple stuff. I use this for, proposal writing, grant proposal writing, other things and so on. So this is one proposal that we set up a multidisciplinary AI center. I just gave it. I'm just showing you the first and the last page. This has 11 pages in my prompt. My prompt was 11 pages long because I wanted to tell it exactly what we wanted to do, what are the implications, what is the background, all that. If I had written this myself, I would have taken few months because I need to gather all the information, think about it. So thinking part I did. Then I get the information, all the information together. I have all the information in my head, what I want to do, what is the background, why I want to do. I just wrote it without thinking about anything, any particular order, nothing. Right? I just put the information there. Then I said, this is the format I want it. Summary, quote about the project, and the social impact, facilities, project budget. Right? And it gave me the output. In Gemini, actually, you can create 3, or in ChatGPT, you can just keep refreshing it until you get multiple versions. So what I do is actually I get all these versions, whichever looks good, I copy it to a Google Doc. I create multiple drafts. I create a main draft, copy from each draft, whatever looks good, put it in a nice, like, very organized manner, which makes sense. Done. Maximum, this one took me, I think, about 2 hours or 3 hours to create entirely, right? Which would have taken me a few months if I had done it previously, definitely, right? To think about it, put together, make, proofread everything. This one, you're putting everything together, put it in right order, it's already, Grammarly is running in the background, it will generate, create, it will, uh, you know, um, correct all the errors as well if there are any, and you're done, right? So this is what we talk about, making things efficient and all that, right? And then we wanted to have a show based on that one. So this one, I entered the proposal for that one, the plan for the inauguration, all those things, and I asked it to create a plan for the inauguration. Like few minutes, right? Give all the information that you have, what your center is about, what type of inauguration you want to have, create a plan, done in half an hour, 1 hour. You're done, right? Because it has, like, it has millions of plans of inaugurations to, source from. It will come up with a better plan that you never thought of, right? And, if you want to use it for learning, like there are different plugins. We can go into, we can look at these things later. There are different plugins. So this is a plugin that we use in tutoring, right? It will actually not give you the answer. If you ask a question, it will try to get you to learn and think and answer and give you a hint and answer. It's the same way that you will teach a class, right? So there are many things like that, right? And earlier somebody was saying about, making, learning things differently, learning. So this is an example I saw somewhere else. This is actually, I did this one, but there's an example I saw somewhere else. Like, for example, this is from one of my favorite stories, Alan Quatermain from Henry Rider Haggard. So it's just like, I want to ask something from Quatermain. So I'm telling ChatGPT, I want to talk to Alan Quatermain. Can you play as him? And then I go and ask him, questions, and then it just answers. I'm asking, what is fear, right? And then he's like, just answering like Alan Quatermain, which makes reading, and because it's very hard to get even my son to read now, because they have a lot of devices. But this makes, learning very interesting and different. And you can do different things with this one, right? Of course, you can use it for deepfake. You can get it to talk like, or write like some particular author or a particular person, how person talks, right? But you can use it for good things. You can use it for bad things as well. And different things. So and this is like prompt engineering. This is example I used in another presentation. Like, what is software engineering would be boring for most of you. Actually, if I look at that one, it's boring for me as well. Like, so what is software engineering? It goes into system design engineering principle. I was like, okay, boring. Can you make it a bit more exciting and fun? And then it goes on to say, okay, think about it like a modern day wizard. You have a wand and a code, and it goes on to tell you a fairy tale, actually. How the wizards are working, how the others are working. It's pretty interesting, actually, to read it. I'm not going to give you, but I can share the slides, right? And right, go on. I said to go on, and it goes into each bit of detail by explaining it like, how it works within the wizard world. So software engineering made so much fun, right? And you can do that. You can ask it to do it in an entirely different way. But this is what prompt engineering is about. You can ask it to do the things the way you want. That's like, yes, most of the language, almost all language. But then it can have hallucinations, it can have misinformation. You have to be careful. It's not a replacement for you, but it will make your life so much easier, right? So much easier. Like, as I said, one of the proposals I made for another grant, that proposal would have normally taken about 6 months, because I had to do all the data gathering, everything. I wrote it in 6 hours. That is what we are talking about. But without me, you can't just tell it and generate it. Right? I have to be there. Exactly. Right? Still, yeah. In the future, we don't know. But at the moment, we have to know how to use it. Right? Right? Lesson planning. This is once again, since we have a lot of lecturers and all that. So, um, so this is like, you can ask it, based on universal design. Uh, um, uh, you can learn, you can use GenAI, ChatGPT, Gemini to come up with lesson plans. Like, so this is introduction to AI. So it gives you entirely the entire breakdown of the lecture, right? Research work, like, breakdown. I wanted to do some LLM based research. Just summarize things very, I mean, whether this is a good topic to use or to work on, I'll now ask ChatGPT or Gemini. Because why? Because it will list everything. Otherwise, I'll have to download like tens of of papers and read through them to understand what, especially if it's a new area. This is like writing patient letters using Gen AI. So there's not much work in this area done at all. But just to summarize and see what can be done, right? Where can I use Gen AI and LLM in patient letter writing? Just give me like, wow, this is great. Yeah, let's go on, right? Just 5 minutes, I have decided, okay, let's do that project. Otherwise, it would have taken days or even months, I don't know. They based on, I mean, most of the time we don't even have access to publications, so it's very hard to find. But this one summarizes to me what the idea is all about, right? Using other the tools like, so in ChatGPT there are other plugin tools like Consensus, which will actually does not have the problem of hallucinating when it comes to research papers. It will actually have ChatGPT, yes, but Consensus actually based on, so Consensus is based on all the previous papers repository, right? So there are, that is 3.5. That is 3.5. From 4 onwards, it's actually live. Yeah, yeah. I mean, I'm just talking about prompt engineering. So this is the same. Yeah, yeah. So yes, so prompt engineering is the same. I mean, I'm not working for OpenAI or ChatGPT. Actually, I use Gemini more than ChatGPT. So these examples happen to be in from ChatGPT. Ah, okay. No, I haven't. So we'll see the usage in the, yeah. Mm. Okay. Okay. Yeah. Yeah. You don't have to. Yes. Yeah. Yeah. So we'll see the usage in the next session, right? Yeah. Yeah. Writing stories and all that. This is from Gemini. Actually, most of the examples I had is from Gemini, but still, yeah, I understand what you're saying. Anyway, so we'll come to basic prompting in the next session. So these are few examples. It's all about how to ask questions and how to get the answers you want. So how to ask questions, what are the different ways you can do it? We'll look at in the afternoon session. Afternoon session in, I think it's start at 4 o'clock. Yes. So I'll see you at 4.
I have few questions. So should I ask right now or in next session?
Others are free to leave because
I think
no
it will
offense,
be
but because I was instructed because they have the opening ceremony afterwards.
okay. Okay. So it will
Or
be
they can leave because I don't want to keep anybody.
actually it will be better if all participants be present here.
Sure, sure.
And I ask the questions because I have some confusions in your slides. So these confusions should need to be addressed in the presence of all the participants. So how about if we come back after the lunch, then I ask these questions in presence of all participants.
So after lunch, we have to go to the opening ceremony.
Okay, so after opening ceremony, when we will have this session,
Okay.
so how about if I have some questions that should be addressed, then we will start on hands-on of AI.
Okay, let's see. Yeah.
Okay, it's fine.
Sure. Yeah, you'll see.